Okay, we're talking here about lesson 1.6, which is talking about center. We're basically going to be talking about the mean, the median, and then how do we decide which one we use, the mean or the median. Okay, you probably remember these from Algebra 1. The mean is your average, the median is your middle number, and we'll talk about how we find those things here in just a little bit. All right, so here is fish sandwiches at McDonald's and the amount of fat they have. Okay, so if you want to find the median, what you're going to do is you first put all the numbers in order. Okay, so take these numbers, put them in order from lowest to highest, and you start crossing them out, crossing them out, crossing them out, crossing them out, until you find the middle number. Okay, that middle number is your median, which means about half of the sandwiches are more and half the sandwiches are less than 19. Okay. You can also do it from a dot plot. Notice on a dot plot you can go 1, 2, 3, 1, 2, 3, 1, 2. So right there at 19 would be the middle number as well. So median, you're just finding the middle. Okay, so next example here, if you here's all the hamburgers at McDonald's and they're fat. So you can put those, represent them two different ways really to find the median. You can put them on a dot plot like this, where you can number them in order here. If you notice, if you start crossing them out, cross it out, cross it out, you come to the middle and there's two numbers in the middle. Remember back, when there's two numbers in the middle, we add them and divide by 2. Okay, so our middle number would be at 24. That would be our median. If you do this over here, once again, you can start cross them out, cross them out, cross out until you get to 22 and 26. Okay, so those two are middle ones. You add them together, divide by 2, just like we did there. Our median would be 24. Okay, so there are that's how you do the median. Median. Okay, now talking about mean. Mean is the average. The way you find the mean of something is you add all the numbers together and divide by how many numbers there are. So it's fancy language for it. It means find the sum of all of our numbers, divide by how many numbers there are. Okay. So if we think about this here, this is the Lawrence High School baseball team. How many do they usually score? How many runs? And here's some data on 21 of their games. So one of their games they scored 0 runs, 3 games they scored 1 run, etc. If you want to find the mean, you would add 0 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 3, 3, 3, 4, 4, 5, 5, 6, 6, 7, 8, 10, and 12. So you add those all up together, divide by how many there are there, 21 games, you get an average of 4.14 runs per game. Now, 12 might be an outlier. They're playing a weak team, they ran up the score on them a little bit. And let's say we take that one out. What happens then? Well, then we only have 20 of them that we're going to add together, right? So if we add all these numbers together, but we don't add the 12 in, we get 3.75. Now, did that one number have a really big impact on our final result here? Yeah, it did. It's kind of like this idea. If I had a home, say home sales in Harrisonburg, I think they usually report median, and I'm going to tell you why they usually do that instead of mean. So median, I think it's around 190,000 probably for to buy a house in Harrisonburg. You have, let's say this is 100,000, 150,000, 200,000, 250,000. Okay, so we have a lot of houses, right around this area. It might have some houses there and some houses there. Okay, but the mean and the median is probably right around there. Now, if this was symmetrical, our mean would be equal to our median if it's symmetrical. Okay? But what happens, this is a very important point, make sure you listen to this. What happens if I have a home that's sold for that sells one house for $1 million? It's an outlier, right? So when there is an outlier, median first. Does our median change much? If I have a bunch of numbers here, and I'm trying to find all those numbers, I have one number out here. Does my middle number really change much? Not really. The middle number was here. It might be in that same spot, or it might move over just a tad little bit. Okay? But if I add this number to my mean, so if I have all these numbers here, and add this number to it and divide by how many there are, that number really brings our mean up this direction. Okay? So our basic idea is this. If there's an outlier, then we want to use the median to say where our middle is. If there's no outlier, then we're going to use our mean. Okay? And that's basically the idea of it. You can see here, if we had this outlier, it made a big difference. And when we included it, it brought our mean up quite a bit. So that's called resistant. The median is resistant to that outlier. Okay? Another interesting point to make is the mean is your balancing point. So if you think about you want to balance something, you can think the mean of that number would be the balance point of if you want to balance something. Okay. Here, comparing the mean and the median here, if we have things that are skewed to the left here, the mean would be about here versus the median, which would be in here. You can see the mean is drawn down towards that skew. The mean is more affected. Here, it's roughly symmetrical. And if it's roughly symmetrical, our mean and our median are going to be very, very close to be the same number. And if it's skewed to the right, okay, the median's here, the mean is going to be drawn down by those bigger numbers right there. So it's more affected by it. Okay, and that is what we're talking about here in 1.6.